we've had a look at matrices, we've seen what they do. Now let's have a look at a system of equations that we can solve with matrices. Here we've got two equations. Now normally the basic way people do this is to solve using simultaneous equations, and you can do that. You can multiply the first equation by 4, the second equation by 5, minus 1 from the other, and you cancel off I1, you find I2, then you put I2 back in to solve for I1. It's quite a long process. Now matrices can make this a lot more simple, or a lot simpler. All we need to do is split it up into proper matrix equations. What we do initially is we take the coefficients, right, of the unknown values. So 25 is the coefficient of I1, 20 is the coefficient of I2 in the first equation. If we take those 4 coefficients, we can put them into a 2 by 2 matrix, like this. 25, 20, 20, 26. So those are values that we know all those numbers. Now then, we've got I1 and I2. Now there's only one I1 and one I2. They're both the same number, so we don't need a 2 by 2 matrix. We need a 2 by 1 matrix. That's 2 rows, 1 column. That'd be I1, I2. And then the results, 24 and 54, are obviously going to be a 2 row, 1 column matrix, like this. 24, 54. Now we can learn how to break them down like that by figuring out how they go back together. If you remember the row times the column principle that we were talking about, that will mean that we got this row times this column is equal to 24. That means 25 times I1 plus, that's that one, times that one, plus 20 times I2 plus 20 times I2, and it equals 24. So you can see if we can break it out of the matrix like that, we can see that this equation is exactly the same as that equation. So the matrix has been built correctly. So then we can take this matrix over to Excel and we'll have a look at how this can be solved. I've already built it for us here in Excel. We've got the 2 by 2 matrix, we've got 2 by 1 matrix, and I've got my other 2 by 1 matrix as my results. It's my unknown values I'm looking for. Essentially what we've got here is we can simplify this to, this is matrix A times matrix B equals matrix C. Now if we just reduce this down to A times B equals C, it's only a case of a simple transposition to solve this equation. So we would have B is equal to C over A. Now I didn't show you in the previous video how to divide matrices. Now the reason for that is you can't divide matrices. What we have to do instead is we have to remember the principle we learned where we said that any number that is a fraction, right, is the power of 1. We can move that number to the top by changing the sign of the power. Right, we can do the same thing here with A. We can move A up by changing the sign from 1 to -1. Essentially what we're going to do is we're going to take the inverse of the matrix A, and then we're going to multiply it by matrix C. So instead we're going to get B is equal to A to the -1 times C. And that there then will give us, the solution for B, to find I1 and I2. So let's just see if that works. So in Excel, the command to inverse a matrix is simply equals, oh, what's that? What's just happened there? Let's try again. Equals M inverse is our command for matrix for Excel. Right, we want to invert that matrix, so close the brackets. Now remember, if we need to fill more than one box, we have to use Control Shift Enter, and that is the inverse of A. So that is A to the power of -1. In here, we now need to put our results, or C, in there. This is C. Let's put that in the middle. Okay, so that's going to be C. I'm going to just put that in the middle because I like it there. So this is going to be equal to these two. Control Shift Enter. They're in there. Now, I1 and I2, or matrix B, is going to be the result we're going to get over here. Let's put that in the middle. So our matrix B, which we've called unknowns in the previous equation, to find B, we need to just do this times this. Now remember the equation for multiplying matrices equals M mult, open brackets. Now matrix A, comma, because we've said multiply already, C, close brackets, Control Shift Enter, and there we go. That is I1 and I2 solved for us. That saved us just knowing how to simply rearrange the matrix and how to invert it. We've managed to solve for I1 and I2 without needing any simultaneous equations. Now this can be used on much larger systems of equations and can save us a lot of time. We had to do it this way around. We had to do this matrix times this matrix because there's something inherently difficult about matrices. Because of the row times the column thing that we talked about before, we've just done that row times that column equals that top number, and this row times the same column equals that number. If we've got a 2 by 2 and we want to multiply by a 2 by 1, let's put them in brackets, the number of columns in our first matrix must be the same as the number of rows in the second matrix. These two numbers have to be the same for this to work. If it is not the same number, if there was only one row there, or say there was 3, if there was another number down here, we wouldn't have enough numbers here to multiply here. So we must have these two numbers must be the same. And the handy thing about it as well is the resultant matrix, this one, will always be a 2 by 1 matrix. So in order to multiply matrices, these two numbers need to be the same, and your resultant matrix will always be these two. See if you can get your heads around that. Have a little play with it, and I'll see you in the next video. Thanks for watching.